In the previous class, we have studied about area. Area of a square is side into side, that is equal to side square units. Area of a rectangle is length into breadth, which is LB square units. Let us revise again through exercise 66. 1. Fill in the blanks. 1. Area of rectangle is length into breadth. 2. Area of square is side into side equal to side square. 2. What is the area of a rectangle with length 4 centimeters and breadth 2 centimeters? Solution. Area of rectangle is length into breadth. Length is equal to 4 centimeters and breadth is equal to 2 centimeters. Therefore, area is 4 into 2, which is equal to 8 square centimeters. Therefore, area of a rectangle is equal to 8 square centimeters. 3. If one side of square is 40 centimeters, what is its area? Solution. Area of a square is side square. Length of the side is given as 40 centimeters. Therefore, area of a square is equal to 40 into 40, which is equal to 1600 square centimeters. Therefore, area of a square is equal to 1600 square centimeters. Let us study some more examples. Example 1. Length of rectangle is 12.5 centimeters and breadth is 10.4 centimeters. Find its area. Solution. Area of a rectangle is length into breadth. Substituting the values of length and breadth, area is equal to 12.5 into 10.4, which is equal to 130 square centimeters. Therefore, area of a rectangle is 130 square centimeters. Example 2. A table is in square shape with one edge measuring 16.4 centimeters. Find the area of its top. Solution. Area of square is side square. Substituting values, we get 16.4 into 16.4, which is 268.96 square centimeters. Therefore, area of the tabletop is equal to 268.96 square centimeters. Let us solve the sums from exercise 67. Question 1. Use the formula to find the area of the rectangles. Length and breadth are given. 1. 32.5 centimeters, 16.2 centimeters. Solution. Length is 32.5 centimeters and breadth is 16.2 centimeters. Area of a rectangle is length into breadth. Substituting the values, we get 32.5 into 16.2, which is equal to 526.5 square centimeters. Therefore, area of a rectangle is equal to 526.5 square centimeters. 2. 14.5 meters, 9.3 meters. Solution. Length is 14.5 meters and breadth is 9.3 meters. Area of a rectangle is length into breadth. Substituting the values, we get 14.5 into 9.3, which is equal to 134.85 square meters. Therefore, area of a rectangle is equal to 134.85 square meters. Question 2. Use the formula to find area of the square. Side of the square is given. 1. 35.5 centimeters. Solution. Side of a square is 35.5 centimeters. Area of square is side square. Substituting the values, we get 35.5 into 35.5, which is equal to 1260.25 square centimeters. Therefore, area of a square is equal to 1260.25 square centimeters. 2. 30.1 meters. Solution. Side of a square is 30.1 meters. Area of square is side square. Substituting the values, we get 30.1 into 30.1, which is equal to 906.01 square meters. Therefore, area of a square is equal to 906.01 square meters. Let us solve some word problems. Example 1. What will be the cost of tiling a rectangular plot of land 35.7 meter long and 8.3 meter broad at the rate of rupees 25 per square meter? Solution. Length of plot is 35.7 meters. Breadth of plot is 8.3 meters. Area of a rectangle is length into breadth. Substituting values of length into breadth, we get 35.7 into 8.3, which is equal to 296.31 square meters. Thus, area of a rectangular plot is equal to 296.31 square meters. Cost of tiling is rupees 25 per square meter. Therefore, cost of tiling 296.31 square meters of plot is equal to 296.31 into 25, which is equal to 7,407.75. Therefore, cost of tiling 296.31 square meters of plot is rupees 7,407.75. Now, let us solve sums from exercise 68. 1. A pit 2 meter long and 2 meter broad is to be dug in a place which is 12.4 meter long and 10.2 meter broad. Find the area of plot left after the pit is dug. Solution. Length of a plot is 12.4 meter. Breadth of a plot is 10.2 meter. Area of plot is equal to length 12.4 into breadth 10.2, which is equal to 126.48 square meters. Therefore, area of a plot is equal to 126.48 square meters. Length of a pit is 2 meter and breadth of a pit is 2 meter. Area of a pit is side square, which is equal to 2 into 2, that is 4 square meters. Therefore, the area of plot left after the pit is dug is equal to area of a plot minus area of pit. This is equal to 126.48 minus 4. It is 122.48 square meters. Therefore, the area of plot left after the pit is dug is equal to 122.48 square meters. 2. The floor of a room of 6.6 meter length and 4.5 meter breadth is to be tiled. How many tiles will be required for this job if each square tile has a side of 30 centimeter? Solution. Length of the floor of a room is 6.6 meter and breadth is 4.5 meter. Area of the floor is length into breadth equal to 6.6 into 4.5. That is equal to 29.7 square meter. Side of tile is 30 centimeters, which is equal to 30 upon 100 meter, that is 0.3 meters. Area of tile is equal to 0.3 into 0.3, which is equal to 0.09 square meter. Number of tiles required is equal to area of floor upon area of tiles. 29.7 upon 0.09, which is equal to 330 tiles. Therefore, number of tiles required for tiling a floor of a room is 330 tiles. 3. Look at the figure and answer the questions. 1. What is the area of part 1? Solution. Part 1 is a rectangle. Length is equal to 4.5 minus 1, which is equal to 3.5 centimeters. Breadth is 1 centimeter. Area is 3.5 into 1 equal to 3.5 square centimeters. Part 2 is square. Side is 1 centimeter. Area is 1 into 1 equal to 1 square centimeter. Part 3 is a rectangle. Length is 6.5 centimeters. Breadth is 1 centimeter. Area is 6.5 into 1 equal to 6.5 square centimeters. Part 4 is rectangle. Breadth is 4.5 minus 1 equal to 3.5 centimeter. Length is 6.5 centimeters. Area is 4.5 into 6.5, which is 22.75 square centimeters. Let us now see how to find one side of a rectangle when area and other side are given. Example 1. Area of a field is 2500 square meters. If its length is 100 meters, find breadth. Solution. Area of a field is 2500 square meters. Length is 100 meters. We know area of a rectangle is equal to length into breadth. Substituting the values, we get 2500 is equal to 100 into breadth. Dividing both sides by 100, we get 2500 upon 100 equal to 100 into breadth upon 100. Therefore, breadth is equal to 2500 upon 100. On simplifying, we get breadth is equal to 25. Therefore, breadth of a field is equal to 25 meters. Example 2. Area of a rectangle is 310.35 square meters. If its breadth is 15.5 meters, find length. Solution. Area of a rectangle is 310.35 square meters. Breadth is 15.5 meters. Area is equal to length into breadth. Substituting the values, we get 310.35 equal to length into 15.5. Dividing both sides by 15.5, we get 310.35 upon 15.5 is equal to length into 15.5 upon 15.5. Therefore, length is equal to 310.35 upon 15.5, which is equal to 20.02. Therefore, length of a rectangle is equal to 20.02 meters. Let us now solve exercise 69. 1. Length of rectangular garden is 120 meters and its area is 7200 square meters. What is its breadth? Solution. Area of a rectangular garden is 7200 square meters. Length is 120 meters. area is equal to length into breadth. Substituting the values, we get 7,200 equal to 120 into breadth. Dividing both sides by 120, we get 7,200 upon 120 is equal to 120 into breadth upon 120. On simplifying, we get breadth is equal to 7,200 upon 120, which is equal to 60 meters. Therefore, the breadth of rectangular garden is 60 meters. 2. The area of the rectangle is 0.192 square meters. If its length is 1.2 meters, what is its breadth? Solution. Area of the rectangle is 0.192 square meters. Length is 1.2 meters. Area is equal to length into breadth. Substituting the values, we get 0.192 equal to 1.2 into breadth. Hence, breadth is equal to 0.192 upon 1.2, which is equal to 0.16 meters. Thus, breadth of the rectangle is 0.16 meters. Let us now solve the word problems based on area. Example 1. The length of a rectangular garden is 90 meters and breadth is 20 meters. There is a 4 meters broad path round this garden. What is the area of the road? Solution. Let x, y, z, w be the garden. It is a rectangular garden. There is a 4 meters wide road round it. A, B, C, D is the road round the garden. Area of a road is equal to area of the road A, B, C, D minus area of the garden X, Y, Z, W. Area of the road A, B, C, D is length into breadth. Length is 90 meters plus 4 meters plus 4 meters, which is 98 meters. Breadth is 20 plus 4 meters plus 4 meters, which is 28 meters. Area is 98 into 28, which is equal to 2,744 square meters. Area of the road ABCD is equal to 2,744 square meters. Area of garden XYZW is length into breadth. Length is 90 meters and breadth is 20 meters. Area is 90 into 20, which is equal to 1800 square meters. Area of a road is equal to area of the road ABCD minus area of the garden XYZW. This is equal to 2,744 minus 1800, which is equal to 944 square meters. Thus, the area of the road is equal to 944 square meters. Example 2. The length of rectangular field is 50 meters and its breadth is 25 meters. Within the field along its sides, there is a 2.5 meter broad path. Find area of path. Solution. PQRS is the garden. Leaving out 2.5 meter broad road on all four sides, we get ABCD, which is also a rectangle. Area of path is area of PQRS minus area of ABCD. Area of PQRS is L into B, where length is 50 meters, breadth is 25 meters. Area is 50 into 25 equal to 1,250 square meters. Area of ABCD is L into B, where length is 50 minus in bracket 2.5 plus 2.5 equal to 45 meters. Breadth is 25 minus 2.5 plus 2.5 which is equal to 20 meters. Area is 45 into 20 equal to 900 square meters. Area of road is 1250 minus 900 which is 350 square meters. Let us solve exercise 70. 1. The length of a rectangular playground is 105 meters and its breadth is 40 meters. Along all four sides there is 3.5 meter broad road surrounding the ground. What is the area of the road? Solution. Let A, B, C, D be the garden. Length of garden is 1005 meters. Breadth of garden is 40 meters. Area of garden is 105 into 40 which is 4200 square meters. Along with road of width 3.5 meter, another rectangle is formed PQRS. Length of PQRS is 105 plus 3.5 plus 3.5 equal to 112 meters. Breadth of PQRS is 40 plus 3.5 plus 3.5 equal to 47 meters. Therefore, area of PQRS is 112 into 47 equal to 5264 square meters. Area of road is equal to area of PQRS minus area of ABCD equal to 5264 minus 4200 which is 1064 square meters. 2. A drawing board is 45 centimeter long and 20 centimeter broad. A 3 centimeter wide border has been lifted along all four sides and a picture drawn inside it. What is the area of the border? Solution. Let ABCD be the board. PQRS is the picture. Area of border is area of ABCD minus area of PQRS. Length of ABCD is 45 centimeters. Breadth of ABCD is 20 centimeters. Area of PQRS is 45 into 20 equal to 900 square centimeters. Length of PQRS is 45 minus 3 plus 3 equal to 39 centimeters. Breadth of PQRS is 20 minus 3 plus 3 equal to 14 centimeters. Area is 39 into 14 equal to 546 square centimeters. Area of border is 900 minus 546 which is 354 square centimeters. 3. One wall of a hall is to be painted leaving a strip of width 1.5 meter along all four sides. If the length of wall is 6 meters and breadth is 5 meters, find the area of the unpainted portion of the wall. Solution. Let ABCD be the wall. PQRS is the painted portion. Area of wall is L into B. Length of wall is 6 meters. Breadth of wall is 5 meters. Area of wall is 6 into 5 equal to 30 square meters. Length of wall painted is 6 minus 1.5 plus 1.5 equal to 3 meters. Breadth of wall painted is 5 minus 1.5 plus 1.5 equal to 2 meters. Area of painted portion is 3 into 2 equal to 6 square meters. Area of unpainted portion is area of wall minus area of painted portion. Area of unpainted portion is 30 minus 6 equal to 24 square meters. Now, let us solve some sums from problem set 2. 1. Side of square handkerchief is 15.2 centimeters. What is its area? Solution. Side of square handkerchief is 15.2 centimeter. Area of square is equal to side square. Therefore, area is equal to 15.2 into 15.2 is equal to 231.04 square centimeters. 2. The area of rectangle is 148.75 square meters. If its breadth is 8.5 meters, what is its length? Solution. Area of rectangle is length into breadth. Substituting values, 148.75 is equal to length into 8.5. That is, length is equal to 148.75 upon 8.5 meters, which is equal to 17.5 meters. 3. The length of a rectangular mat is 4 meters and its breadth is 2.5 meters. A 0.1 meter wide border is attached to it on all 4 sides. What is the area of border? Solution. Let PQRS be the mat. Length of mat is 4 meters. Breadth of mat is 2.5 meters. Area of mat is 4 into 2.5 equal to 10 square meters. ABCD is formed after attaching the border. Length of ABCD is 4 plus 0.1 plus 0.1 equal to 4.2 meters. Breadth is 2.5 plus 0.1 plus 0.1 equal to 2.7 meters. Area of ABCD is 4.2 into 2.7, which is 11.34 square meters. Therefore, area of border is area of ABCD minus area of PQRS equal to 11.34 minus 10 equal to 1.34 square meters.
We all know there are various shapes like rectangle, square, quadrilateral, rhombus, etc. Let's learn how to find their area. What is area? Area is the measure of the region bounded by the circumference. To find the area of any shape, we need to remember certain formulae. Bear in mind that the answer to the area of any shape should always be written as square meter or square centimeter as the unit is mentioned in the question. To begin, let's start with the area of a rectangle. What is a rectangle? A rectangle is a four-sided figure with length and breadth having its opposite sides equal and each angle of a rectangle measures 90 degrees. Now let us draw a rectangle and find out its area with the given length and breadth. 1. Let's draw a rectangle ABCD with length AB equal to 8 meter and breadth BC equal to 5 meter. The formula to calculate the area of a rectangle is the area of a rectangle is equal to the length of a rectangle into the breadth of a rectangle. Area is equal to length AB into length of BC, which is equal to 8 meter into 5 meter. Therefore, area is equal to 40 square meter. Hence, the area of rectangle ABCD is 40 square meter. 2. Let us draw a rectangle PQRS with length PQ as 5.2 centimeter and breadth QR as 2.5 centimeter. The area of a rectangle is equal to the length of a rectangle into the breadth of a rectangle. Substituting in the formula, we get area is equal to length PQ into length QR, which is equal to 5.2 centimeter into 2.5 centimeter. The easiest way to multiply is just multiply 52 by 25 and then put the decimal point before 2 places from the behind. Why 2 places? Because length is having 1 decimal place after the decimal point, and the same is with the measure of the breadth. Therefore, area of rectangle PQRS is equal to 13 square centimeter. Let us consider a sum in which the area of a rectangle is given, but either the breadth or the length is not given. 3. Draw a rectangle EFGH whose length EF is 6 centimeter and area is 30 square centimeter, and you have to find the breadth. The area of a rectangle is equal to the length of a rectangle into the breadth of a rectangle. Area of rectangle EFGH is equal to length EF into length FG. By substituting the values, we get 30 square centimeter is equal to 6 centimeter into length FG. Dividing both sides by 6, we get 30 divided by 6 is equal to length FG. Therefore, length FG is equal to 5 centimeter. Therefore, the length of the rectangle EFGH is equal to 5 centimeter. In the data provided here, breadth and area is given, but length of the rectangle is not given. 4. Let us draw a rectangle ABCD with area of the rectangle ABCD as 3.15 square centimeter and breadth BC as 1.5 centimeter, and you have to find the length. The area of a rectangle is equal to the length of a rectangle into the breadth of a rectangle. Area of rectangle ABCD is equal to length AB into length BC. Substituting, we get 3.15 square centimeter is equal to length AB into 1.5 centimeter. Dividing both sides by 1.5, we get 3.15 divided by 1.5 is equal to length AB. First, remove the decimal point so that it becomes easy to divide. That is, 3.15 into 100 upon 1.5 into 100 is equal to length AB. That is, 315 upon 150 is equal to length AB is equal to 2.1 centimeter. Therefore, the length of the rectangle ABCD is 2.1 centimeter. Now, let us learn how to find out the area of a square. What is a square? A square is also a four-sided figure with all its sides equal. That is, equal length and equal breadth, and each angle measures 90 degrees. Let us solve some sums on square. 1. Draw a square ABCD having its sides measuring 25 centimeter and find its area. The formula to calculate the area of a square is the area of a square is equal to a square of side of a square. Substituting the formula, we get area of square ABCD is equal to 25 centimeter into 25 centimeter, which is equal to 625 square centimeter. Hence, the area of square ABCD is 625 square centimeter. We shall now see the area of a square with a decimal. 2. Let us draw a square PQRS having its sides measuring 2.8 meter. Find its area. The area of a square is equal to square of side of a square. Substituting the formula, we get area of square PQRS is equal to 2.8 meter the whole square, which is equal to 2.8 meter into 2.8 meter, multiplying 28 into 28 and adding a decimal point before 2 places from units. We get 7.84 square meter, which is area of the square. Therefore, the area of square PQRS is 7.84 square meter. We will now see how to find out the side of a square when the area of a square is given. 3. The area of the square EFGH is 225 square meter. Find the side of the square. The area of a square is equal to the square of side of a square. Substituting, we get 225 square meter is equal to side of a square, the whole square. Therefore, the side of the square is square root of 225, that is 15 meter. Thus, the side of the square EFGH is 15 meter. Let us see a sum where the area of a square is given in decimal and the side is not given. 4. The area of a square ABCD is 7.84 square centimeter. Find the side of the square ABCD. The area of a square is equal to side of a square, the whole square. Substituting the formula, we get 7.84 square centimeter is equal to side of the square, the whole square. Therefore, the side of the square is square root of 7.84, that is 2.8. Thus, the side of the square ABCD is 2.8 centimeter. Now we shall learn how to find the area of a parallelogram. The area of parallelogram is equal to base into height. Now we shall try to find the area of a parallelogram. 1. Draw a parallelogram ABCD whose base BC is 12 cm and height AE is 7 cm. What would be its area? Given. Base is equal to 12 cm. Height is equal to 7 cm. Find area. As per the formula, area of a parallelogram is base into height. Therefore, substituting we get area of a parallelogram ABCD is equal to length BC into length AE, which is equal to 12 cm into 7 cm, which is equal to 84 square centimeter. Hence, the area of a parallelogram ABCD is 84 square centimeter. We shall now learn how to find the base or the height of the parallelogram when the area of a parallelogram is given. 2. The area of parallelogram ABCD is 26 square centimeter. If its base is 6.5 centimeter, what is its height? Given. Area is equal to 26 square centimeter. Base is equal to 6.5 centimeter. We have to find height. Area of a parallelogram is base into height. Area is equal to length BC into length AE. Therefore, by substituting, we get 26 square centimeter is equal to 6.5 into length AE. Therefore, length AE is equal to 26 divided by 6.5. First, remove the decimal point by multiplying the numerator and denominator by 10. 26 into 10 divided by 6.5 into 10, which is equal to 260 divided by 65, which is equal to 4 centimeter after reducing to the lowest term. Therefore, the height of the parallelogram ABCD is 4 centimeter. In the same way, you can find the base of a parallelogram when the area and height of the parallelogram is given. We shall now see how to find the area of a triangle. Area of a triangle is equal to 1 upon 2 into base into height. Area of a right angle triangle. Area of a right angle triangle is equal to 1 upon 2 into products of the lengths of the sides forming the right angle. Let us now solve the sums based on the area of a triangle. 1. A certain triangular plot has a base 20 meter and a height 30 meter. What is its area? Given. Base is equal to 20 meter, height is equal to 30 meter. We have to find the area. As per the formula, area of a triangle is equal to 1 upon 2 into base into height. By substituting, we get area of a triangle is equal to 1 upon 2 into length BC into length AB, which is equal to 1 upon 2 into 20 meter into 30 meter. Reducing to the lowest term we get, which is equal to 300 square meter. 2. We shall now find out the area of a triangle whose base is 18.2 centimeter and height is 7.5 centimeter. Given base is equal to 18.2 centimeter, height is equal to 7.5 centimeter. We have to find area. Area of a triangle is equal to 1 upon 2 into base into height. By substituting, we get area of a triangle is equal to 1 upon 2 into length BC into length AB, which is equal to 1 upon 2 into 18.2 centimeter into 7.5 centimeter. Reducing to the lowest term, we get 1 into 9.1 centimeter into 7.5 centimeter, which is equal to 68.25 square centimeter. Therefore, the area of the triangle ABC is 68.25 square centimeter. We shall now try to find the area of a right-angled triangle. 3. The sides of a right-angled triangle forming the right angle are 16 centimeter and 8 centimeter. What is its area? Given two sides of a right-angled triangle is 16 centimeter and 8 centimeter. We have to find area. Area of a right-angled triangle is equal to 1 upon 2 into products of the lengths of the sides forming the right angle. Substituting, we get area of a right-angled triangle is equal to 1 upon 2 into 16 centimeter into 8 centimeter. Reducing to the lowest term, we get area of a right-angled triangle is equal to 8 centimeter into 8 centimeter, which is equal to 64 square centimeter. Hence, area of a right-angled triangle is equal to 64 square centimeter. We shall now see how to find the base or the height of a triangle when the area of a triangle is given. 4. A triangle has an area of 11.6 square centimeter. If its height is 2.9 centimeter, what is the base? Given area is equal to 11.6 square centimeter, height is equal to 2.9 centimeter. We have to find the base. Draw the figure and name it as per the formula. Area of a triangle is equal to 1 upon 2 into base into height. By substituting, we get 11.6 square centimeter is equal to 1 upon 2 into length BC into 2.9. Multiplying both sides by 2 to remove the denominator, we get 11.6 square centimeter into 2 is equal to 1 upon 2 into length BC into 2.9 into 2. 2 from the numerator and the denominator on the right-hand side of the equation get cancelled. Therefore, we get 11.6 into 2 is equal to length BC into 2.9. That is, 23.2 is equal to length BC into 2.9. Dividing both sides by 2.9, we get 23.2 divided by 2.9 is equal to length BC into 2.9 divided by 2.9. 2.9 from the numerator and from the denominator on the right-hand side of the equation gets cancelled. And therefore we get length BC is equal to 23.2 divided by 2.9. Now multiply both sides, that is numerator and denominator, by 10 to remove the decimal point. We get length BC is equal to 23.2 into 10 divided by 2.9 into 10. Therefore, length BC is equal to 232 divided by 29, which is equal to 8 centimeter. Hence, the length of the triangle ABC is 8 centimeter. Similarly, we can also find the height of a triangle when the area and base of the triangle is given. We will now learn how to find the area of an equilateral triangle. The formula to find the area of an equilateral triangle is area of an equilateral triangle is equal to square root of 3 by 4 into side square. Let us now solve a sum relating to this formula. Exercise 24. 1. What shall be the area of an equilateral triangle if its side is 12 cm? As the formula states, area of an equilateral triangle is equal to square root of 3 by 4 into side square. By substituting, we get area of an equilateral triangle is equal to square root of 3 by 4 into 12 the whole square, which is equal to square root of 3 by 4 into 12 into 12. By reducing, we get 36 square root 3 square centimeter. Therefore, the area of the equilateral triangle ABC is 36 square root 3 square centimeter. Now we shall learn to find the area of a rhombus. The formula to find the area of a rhombus is as follows. Area of a rhombus is equal to 1 upon 2 into product of the lengths of the diagonals. Let us solve exercise 25. 1. Let us find out the area of a rhombus ABCD whose diagonal AC measures 84 cm and diagonal BD measures 42 cm. Given. One diagonal is 84 cm and other diagonal is 42 cm. To solve, area of a rhombus is equal to 1 upon 2 into product of the lengths of the diagonals. By substituting, we get area of a rhombus is equal to 1 upon 2 into diagonal AC into diagonal BD. Therefore, area of a rhombus is equal to 1 upon 2 into 84 into 42. By reducing, we get area of a rhombus is equal to 1764 square centimeter. The area of the rhombus ABCD is 1764 square centimeter. Similarly, we can also find the length of any one diagonal when the area of a rhombus is given. 2. The area of a rhombus PQRS is 1280 square centimeter. If diagonal PR is 64 centimeter long, what is the length of the other diagonal, that is QS? Given the area of a rhombus is equal to 1280 square centimeter, one diagonal PR is equal to 64 centimeter, and you have to find the other diagonal, that is QS. As usual, first write down the formula. Area of a rhombus is equal to 1 upon 2 into product of the lengths of the diagonals. By substituting, we get 1280 is equal to 1 upon 2 into 64 into length QS. Multiplying both sides by 2, we get 1280 into 2 is equal to 1 upon 2 into 64 into length QS into 2. Cancelling 2 from the numerator and denominator on the right hand side, we get 1280 into 2 is equal to 1 into 64 into length QS, that is 2560 is equal to 64 into length QS. Dividing both sides by 64, we get 2560 divided by 64 is equal to 64 into length QS divided by 64. 64 gets cancelled on the right hand side and we get 2560 divided by 64 is equal to length QS, which is equal to 40 centimeter. Therefore, length QS is equal to 40 centimeter. Therefore, the length of the other diagonal QS is 40 centimeter. We shall now see how to find the area of a trapezium. In this figure, PQ is parallel to SR and PM is perpendicular to SR. Segment PM is the height of the trapezium. The formula for area of trapezium is area of a trapezium is equal to 1 upon 2 into the sum of the lengths of the parallel sides into height. Let us try to solve certain sums based on area of trapezium. Exercise 26. 1. The lengths of the parallel sides of a trapezium ABCD are 8.7 cm and 5.3 cm. If the perpendicular distance between them is 4.5 cm, what is its area? Given AB is equal to 5.3 cm, CD is equal to 8.7 cm, AM, that is the height, is equal to 4.5 cm. We have to find the area. As the formula says, area of a trapezium is equal to 1 upon 2 into the sum of the lengths of the parallel sides into height. Area of a trapezium is equal to 1 upon 2 into the sum of the lengths of the parallel sides, that is, AB plus CD into height AD. By substituting, we get area of a trapezium is equal to 1 upon 2 into 5.3 plus 8.7 into 4.5, which is equal to 1 upon 2 into 14 into 4.5. By reducing, we get area of a trapezium is equal to 31.5 square centimeter. Therefore, the area of the trapezium ABCD is 31.5 square centimeter. Now we shall learn how to find the sum of the parallel sides when the area of a trapezium is given and the height is given. 2. The area of a trapezium is 262.5 square centimeter and the perpendicular distance between its parallel is 15 centimeter. What is the sum of its parallel sides? Given area is 262.5 square centimeter. AM, that is the height, is equal to 15 centimeter. AB plus CD is equal to question mark. Area of a trapezium is equal to 1 upon 2 into the sum of the lengths of the parallel sides into height. Area of a trapezium is equal to 1 upon 2 into the sum of the lengths of the parallel sides, that is, AB plus CD into height AD. By substituting, we get 262.5 is equal to 1 upon 2 into the sum of the lengths of the parallel sides into 15. Multiplying both sides by 2, we get 262.5 into 2 is equal to 1 upon 2 into the sum of the lengths of the parallel sides into 15 into 2. 2 from the numerator and denominator gets cancelled on the right hand side, and hence we are left with 525 is equal to the sum of the lengths of the parallel sides into 15. Therefore, keeping sum of the lengths of the parallel sides on one side, we get, dividing both sides by 15, 525 divided by 15 is equal to the sum of the lengths of the parallel sides into 15 divided by 15. Thus, 15 from the numerator and denominator gets cancelled on the right hand side, and we get 525 divided by 15 is equal to the sum of the lengths of the parallel sides. Therefore, the sum of the parallel side is equal to 35 centimeter. 3. The area of a trapezium is 84.5 square centimeter and its height is 6.5 centimeter. If one of its parallel sides is 15.2 centimeter long, what is the length of the other side? As usual, first draw a trapezium. Name and write the formula. Given area is 84.5 square centimeter. DM, that is the height, is equal to 6.5 centimeter. AB is equal to 15.2 centimeter. We have to find the length of CD. Let the measure of other diagonal be x. Area of a trapezium is equal to 1 upon 2 into the sum of the lengths of the parallel sides into height. By substituting, we get 84.5 is equal to 1 upon 2 into 15.2 plus x into 6.5. Multiplying both sides by 2, we get 84.5 into 2 is equal to 1 upon 2 into 15.2 plus x into 6.5 into 2. 2 from the numerator and the denominator get cancelled on the right hand side. And now we have 169 is equal to 15.2 plus x into 6.5. Dividing both sides by 6.5, we get 169 upon 6.5 is equal to 15.2 plus x into 6.5 upon 6.5. Thus, 6.5 from the numerator and the denominator get cancelled on the right hand side. And now we have 169 upon 6.5 is equal to 15.2 plus x. Multiplying the numerator and the denominator by 10 to remove the decimal point, we get 169 into 10 upon 6.5 into 10 is equal to 15.2 plus x. Hence, now we have the equation as 1690 upon 65 is equal to 15.2 plus x. By reducing, we get 26 is equal to 15.2 plus x. Subtracting both sides by 15.2, we get 26 minus 15.2 is equal to x. That is, 10.8 is equal to x. Therefore, the measure of other diagonal is 10.8 centimeter. Now we shall see how to find the area of a triangle when you are given 3 different measures of the sides of the triangle. A triangle ABC in which the side AB is C, side BC is A, and side AC is B as shown in the figure. In such a case, the perimeter of triangle ABC will be equal to A plus B plus C, and the semi-perimeter will be equal to A plus B plus C divided by 2. The area of such a triangle will be square root of the whole semi-perimeter into semi-perimeter minus the first side into the semi-perimeter minus the second side into semi-perimeter minus the third side. This formula is known as the Heron's formula. Let's now solve few sums. 1. If the sides of a triangle are 25 cm, 39 cm and 56 cm, what is the area of this triangle? Assumed side AB is 25 cm, side BC is 39 cm, side AC is 56 cm. We have to find the area of this triangle. In such type of sums, to find the area, you will always have to find the semi-perimeter of the triangle. As the formula says, the semi-perimeter S of the triangle is equal to A plus B plus C divided by 2. By substituting, we get semi-perimeter is equal to 25 plus 39 plus 56 divided by 2, which is equal to 120 divided by 2, which is equal to 60 cm. Now we can easily find the area of this triangle. The formula for area of such triangle is square root of the whole semi-perimeter into semi-perimeter minus the first side into the semi-perimeter minus the second side into semi-perimeter minus the third side, which is equal to square root 60 into 60 minus 25 into 60 minus 39 into 60 minus 56, which is equal to square root 60 into 35 into 21 into 4. Now to solve it further, you should factorize the numbers in such a way that there should be repetition of the numbers so that one group gets cancelled as we have to do square root. In our sum, 60 can be factorized as 2 into 2 into 3 into 5. 35 can be factorized as 5 into 7. 21 can be factorized as 3 into 7. 4 can be factorized as 2 into 2. Now making groups with 2 equal factors in each group and taking in one factor from each group, we get area is equal to 2 into 2 into 3 into 5 into 7. Multiplying these numbers, we get area is equal to 420 square centimeter. Therefore, the area of the triangle is 420 square centimeter. 2. How much will it cost to have a triangular field weeded at the rate of Rs 2 per square meter if the length of the field's sides are 11 meter, 61 meter and 60 meter? Given. Side A is 11 meter, side B is 61 meter, side C is 60 meter. We have to find the area of this triangle. To find the cost, we have to find the area, and to find the area, we have to find the semi-perimeter of the triangle. As the formula says, the semi-perimeter S of the triangle is equal to A plus B plus C divided by 2. By substituting, we get semi-perimeter is equal to 11 plus 61 plus 60 divided by 2, which is equal to 132 divided by 2, which is equal to 66 meter. Now we shall find the area. Area of the triangle is equal to square root of the whole semi-perimeter into semi-perimeter minus A into the semi-perimeter minus B into semi-perimeter minus C. Substituting, we get square root 66 into 66 minus 11 into 66 minus 61 into 66 minus 60, which is equal to square root 66 into 55 into 5 into 6. Factorizing the numbers, that is, in our sum, 66 can be factorized as 2 into 3 into 11. 55 can be factorized as 5 into 11. 5 could not be factorized further, so it remains the same. And 6 can be factorized as 2 into 3. Now making groups with 2 equal factors in each group and taking in one factor from each group, we get area is equal to 2 into 3 into 5 into 11. Multiplying these numbers, we get area is equal to 330 square meter. Therefore, the area of the triangular field is 330 square meter. Since we have to find the cost of this triangular field weeded, we shall multiply the area of the field with the rate of weeding per square meter. So, cost of weeding is equal to rate into area, which is equal to 2 into 330, which is equal to 660 rupees. Therefore, the cost will be rupees 660 for weeding the field. 3. Use Heron's formula to find the area of the equilateral triangle whose side is P. Given. Since an equilateral triangle has all sides equal, therefore, side A is equal to B is equal to C is equal to P, and we have to find the area of the equilateral triangle. As the formula says, the semi-perimeter S of the triangle is equal to A plus B plus C divided by 2. Substituting, we get which is equal to P plus P plus P divided by 2, which is equal to 3P divided by 2. Semi-perimeter of the triangle is equal to 3P upon 2. Now we can find the area of the triangle. Area of the triangle is equal to square root of the whole semi-perimeter into semi-perimeter minus A into the semi-perimeter minus B into semi-perimeter minus C. Substituting, we get area is equal to square root 3P upon 2 into 3P minus P upon 2 into 3P minus P upon 2 into 3P minus P upon 2. Therefore, area is equal to square root 3P upon 2 into P upon 2 into P upon 2 into P upon 2. As we have P upon 2 4 times, their square root will be 2 times, and hence we get area of the equilateral triangle is square root of 3 into P upon 2 into P upon 2, and hence area is equal to square root of 3P square upon 4. 4. In the figure, PQRS is the map of a plot of land. Using the given measures, find the area. As you see that there are two triangles, triangle PQS and triangle SQR, we have to find the area of these triangles separately and then add the two areas to get the area of the quadrilateral PQRS. Given. Triangle PQS is a right-angled triangle at P with PQ 9 meter and PS 40 meter. The area of the triangle PQS can be found easily by using the formula area of a right-angled triangle is equal to 1 upon 2 into products of the lengths of the sides forming the right angle. By substituting, we get in triangle SQR, we have the base as QR, which is equal to 60 meter, and the height ST as 13 meter. Area of a triangle is equal to 1 upon 2 into base into height. By substituting, we get, after getting the two areas of the triangle, add the two areas to get the area of the quadrilateral PQRS. Therefore, the area of the quadrilateral plot is equal to 570 square meter.